Alkynes can undergo many of the same addition reactions, or very similar addition reactions, to alkenes. For instance, we can reduce alkynes by catalytic hydrogenation. Now this will reduce both pi bonds and take our alkyne all the way to an alkane. So our starting compound here is 2-hexyne, and we're going to reduce it all the way to hexane. Now, what do we do if we want to reduce to the alkene? Well, we need to only reduce once instead of twice. To do that, we need a poisoned catalyst. Two examples of poisoned catalysts are Lindlar's catalyst and P2, which is an Ni2B complex. Lindlar's catalyst includes quinoline, which is this bicyclic here, palladium and barium sulfate in methanol. So, what this will look like, reagent-wise, is H2 Lindlar or H2 Ni2B. But actually, stereochemically, the result is a cis-alkene, not a trans-alkene. So the methyl group would be here, and that would be a hydrogen. Poison catalysts only catalyze reduction of the first pi bond, but not the second. So, you stop at the cis-alkene. Now you're probably wondering how we can get a trans-alkene from an alkyne. The answer? Dissolving metal reduction. And the set of reagents is sodium metal in liquid ammonia, Na/NH3. The slash indicates that the ammonia is the solvent. Do not confuse this with NaNH2, which is sodium amide. NaNH2 is done in NH3. But the slash means a solvent. So these two are not the same thing. In the first step of the mechanism, we get this interesting pattern that they call nucleophilic attack, where the single electron from sodium pairs up with one electron from one of these pi bonds over here, and then the other one goes over here. This gives us a radical anion. So, the negative charge is associated with the lone pair. And the reason we get the trans configuration is because of steric interference between these two electron clouds. Our second step is proton transfer, where the ammonia donates a proton to the radical anion. So this radical that's produced after the second step represents that first pi bond halfway reduced. And then another sodium atom is going to do this nucleophilic attack thing again, donating its electron to make a lone pair to give us an anion. In our final step, this anion, this alkynide, is going to take another proton from another ammonia molecule. Again, that's our solvent, so there's plenty. And this is just a proton transfer reaction. And boom, we've got our trans-alkene. So here's a question for you to consider. If we had 2-pentyne and we wanted to make cis-2-pentene, which reagent or reagents would we use?